In this video, I'm going to show you how to use Excel to calculate some basic descriptive statistics. In this data set, we have hours slept last night for 13 cases, 13 students. I'm pretending these are the 13 students in our class, but of course I just made up this data. Descriptive statistics, as you know, are those measures of central tendency that give us an idea of the dispersion of our data. It can also include our variance and our standard deviation. And so I'm going to show you how to do all of these things within Excel. So the first thing that I'm going to want to do here is our three measures of central tendency, our mean, our median, and our mode. And to calculate these, we're going to use functions that exist in Excel. The first of those is to calculate the mean. That function is called average. Now, to create a formula in Excel, you always start with an equal sign, and then you could just I could just do a mathematical formula here where I added up each of these and then divided by the total count here. But because a function already exists that can do that for me, I'm going to use the Excel function. If I didn't know what my Excel functions were, I could come through here and go insert, here we go, formulas, and I could find what I needed, probably under more functions, statistical, and there's average, which is the one that I want. I already know what it is, so I don't need to use this, but it's telling me what do I want to average. I could just average numbers, or I could tell it I want this full range of data here. I'm going to cancel out of that because I would prefer to just enter my functions. Equal, average, open parentheses, and then I'm going to highlight my range of data from cell A2 through cell A14. Click, hold, release, double check and make sure it's the right one, then close parentheses. And that's all there is to the formula or the function that will calculate a mean of our data. And hit the enter button. There we go, there's a mean. Use the exact same process for median. Again, I know what the function is. I know it's median. And in fact, Excel tries to help me here when I started to type by telling me which my function was. Open parentheses, click, pull, release to highlight, close parentheses, hit enter. And then mode. Again, here I know that it's mode. If I needed to look it up, I could. Actually, it's not mode. My apologies. In this version of Excel, it is, there's multiple options here for mode. Mode mult, mode single, or this one, which is just straight mode, which is actually what's called a deprecated function. It's technically no longer in use. We want to do mode single, which is giving us the one most common data point in our data set, SNGL. If I had wanted to do the two most, I would have chose multiple, and so on. Open parentheses, click, drag, release to highlight my data, close parentheses, and there. Okay, so now I have my mean, median, and mode calculated within Excel. If I wanted to find out what the smallest number in my data set was, I mean, it's pretty easy here. We can kind of see it, but if I had hundreds and hundreds of elements in my data set, that would become really hard. If I want my minimum, and let's say I also want my maximum, and maybe I want some quartiles also. What's the first 25%, second 25%, third 25%, to the last 25%. Usually, I mean, I could go up to quartile 4, but the quartile 4 is going to be the same as the maximum. All right, so again, functions. Equal, and in this case it's min. There we go. I could always check if I needed to be sure. Min. Oops, I misspelled it. There we go, min. Open parentheses. Highlight my data, close parentheses, enter. This one, equal, max, open parentheses, highlight my data, close parentheses, enter. Quartile. Now, quartile is a little bit different because we're going to need to give it two pieces of information, both the range of data and which quartile do we want. So in this case, the formula or the function is just the word quartile. Now, it's telling me that just using the word quartile is a deprecated function. I need to choose inc or x. Those have to do with two different methods of calculating the quartile. One of them takes the midpoint or the median into account in both the second and third quartiles, and the other does not. I'm going to go ahead and use inc, and you can just use that one. Okay, so quartile inc. Try not to misspell it. There we go, INC. Now I open my parentheses. Again, I tell it my data range. And then I use a comma and tell it I would like the first quartile. Okay, so the end of the first quartile. So it's letting me know what my options are to put into that. So its minimum value is 0, and the first quartile, median value, third quartile. I want the first quartile. Close parentheses, hit the enter. I'm going to repeat that here. Quartile dot inc, open parentheses, highlight my data, comma, and then I want second quartile, which is also going to be the same as our median. There we go. And then I want my third quartile. So equals quartile dot inc, open parentheses, highlight my data range, there, 3, 1, enter. And I could do quartile 4 here, which is just going to be the same as the maximum, but a little more practice. Quartile dot inc, open parentheses, there we go, 4. Enter. All right, so now I have my measures of central tendency, my measures of dispersion, essentially, minimum, my range measures actually here. And then now we also need our variance and our standard deviation, because we know those are important parts of understanding how our data, to what extent our data varies around the mean. And so you've read a little bit about that already, but you need to know how to calculate that here in Excel. So there's a couple of different ways that we could choose this. I'm going to insert some space here. So I just highlighted that line, came back to home, and insert, insert, insert. One way is to literally recreate the formula for variance and standard deviation, and the other is to use an existing function for variance and standard deviation. I'm going to show you both of these. So the first thing I want to do is I want to add a new column here, which is just going to be the mean. We know that mean is, I'm going to truncate that a little bit and say 6.8. So that mean is 6.8. And I'm going to highlight that. I'm going to do Control C or Command C to copy, or I could have just come up here to my copy menu. And then I'm going to highlight and paste. There we go. So we've got all those means. And then the variance, or the error, is calculated based on the error. So error is just whatever the difference is between the mean and the data point. So I'm going to say, okay, for this cell, and I want to subtract that cell. Enter. So there's a 1.2 hour difference between the hours the student slept and the mean. Positive 1.2. I'm going to copy, and this is copying that formula, and it shifts down. It changes, as you can see, so now it's A14, B14. Right, so now we've got all of those. Some are positive, some are negative. Then we need to square our error. Again, this is part of the formula for variance, is that we need that squared error. Squaring the error will remove the negatives, basically. Oops, I did not mean to do that. I need the times sign, and then I'm going to, so it's just times itself. There's a square formula also, but I'm just doing the times here. And for some reason it's not, it's because, it's because I don't want C28, I want C2. There's nothing in C28. There we go, there's our squared error. And then I'm going to copy and paste that formula down. So now I have all my squared errors. Variance is the average of the squared errors. So in this case, I want equals average, open parentheses, this set of data, close parentheses, there. So there's my variance. I'm just going to type the word variance in here so we have that identified. Variance equals. There we go. It's a pretty big variance. Just again, if you haven't used Excel a lot, you might not know these things. I don't want to look at that whole range of stuff. I don't want to get rid of it, but I don't want to look at it. So I highlighted that cell and it came up here. I'm going to shrink my visible decimal level. There we go. Variance of 3.36. And the variance is important, you'll find, as we do other things in our statistics, but it's the average squared error. What we're really more interested in is our standard deviation. Now, this is assuming we did the variance calculation for an entire population. It's the entire population of Sociology 299. Again, I know it's fake data, but still. It's a little bit of a different formula if you're doing variance and standard deviation for a sample, and we'll do that next. The standard deviation is simply the square root of the variance. I'm going to use a predefined, there we go, Excel function, SQRT, of that. So now we know our standard deviation is 1.83333. I'm going to shrink that down a little so that we're there. Okay, so we have used Excel and used our formulas that we know for variance and standard deviation. Kind of a pain in the butt. Good to do it to practice using Excel, but really, I could have just done this. Equals variance, calculates variance basis. So I'm going to do var.p, population variance, and then highlight my data. Bingo. Guess what? I could do the same thing here. Equals stdev.p, so that's for a population. stdev.p. Highlight my data. Close there. So you can see how functions make things a lot easier in Excel, like way easier. And that was kind of a nice way to handle that. Now let's not pretend, but we treated this like it was a population. If we were going to be dealing with it like it were a sample, so maybe it's a sample of all students, not a representative or random sample, but it is still a sample of all students on campus, you calculate variance and standard deviation a little bit differently. In that case, what you want to do is you don't do an average, a regular average where you add all of these things up and divide by the number of data elements there. You add it all up and you divide by the number of data elements minus 1. That's that n minus 1 in the formula for sample variance. So this would be different. I couldn't use average because what I would need to do is actually equals sum, open parentheses. In this case, it's the sum of the squared error. So here I've got the sum that just says add all these things up of the squared error, close parentheses, divide by symbol. And then now I need it to do what's called count minus 1. So I want to do count, which is a function that tells me how many things are there here. Oh wait, I don't have to count it myself. And then I just need to do minus 1. So this is going to add those up and divide it by the total count here, minus 1. All right, so you'll notice that the variance is a little bit smaller. Standard deviation is going to operate the exact same way. It's because we've already done that, it's just square roots that. We've already accounted for that n minus 1 when we calculated our variance, so all we need to do now is the square root. I could copy this over to here and it'll translate to there. So the standard deviation is a little bit smaller. In reality, I would not even bother doing any of that because I already understand. I've got some functions that will do this for me. So equals variance S. It's the sample variance. So var.s for my data. And it turned out differently. That means I made a mistake here, and I'm not quite sure what my mistake was. Drat. Now normally what I would do with this video is like stop and edit it or fix it or something, but I'm not really going to because, yeah, I'm not sure what I did wrong there. There's something wrong in my formula. There. We're going to pretend it never even happened. Ha ha. Okay, so, and for this one, this is going to be equal stdev dot s for sample. And then let's gather up our data. Okay. I should have known when I originally did those formulas with the count -1 that something was wrong. I did something wrong. I'm not sure what, but I did something wrong. I'll figure it out later. We can talk about it. Because the number was smaller than this. The whole idea behind doing that count -1 or that n-1 when you calculate the variance and standard deviation for a sample is it's basically being more conservative. It's expecting to see more error or more variance or more deviation from the mean for a sample than it would for the full population. So it is being a little more conservative with that n-1. As a result, the sample variance and standard deviation should always be slightly larger, or in some cases a lot larger, than the population variance and standard deviation. The larger your sample gets, the less of an impact that has, because n-1 when your n is 1,000 is just not that big of a deal. N-1 when your n is 14 is a little bit more of a deal. It's not a huge difference, 3.64 versus 3.36. and 1.9 versus 1.83, but it is a little bit of a difference. I'm going to highlight these and pop those down so we can compare better. So this is now our population. Just going to do a pop. This is our, if this were a sample, and that's if it were a population. So that is basic descriptive statistics in Excel. I wanted you to see how to do this, and I want you to practice doing this because you're not always going to have statistical software available to you to do these kind of things. Now, sometimes Excel has plugins that allow you to do all sorts of really cool things without even having to worry about it. I don't have my statistical analysis plugin on this particular Excel. But if I had a statistical analysis plugin, I wouldn't even have to do that much trouble in order to get these basic descriptive statistics. But that is descriptive statistics in Excel.